So before we go on to forward error correction, one last topic to get over, and that is parity. And in parity, the idea is to identify errors, but we don't necessarily correct them. A very typical parity would be even parity or odd parity. So in this case, it's like a code, and we would say that there were k bits which were uncoded, and I'm going to add one bit, which is the parity bit, the traditional parity bit, that I'll add. So for instance, in this case, we would look at 0, 1, 0, 1, 0. So I have 3 zeros and 1, 1. So I add a 0, and now the parity is even, because I have I always have an even number of 1 and 0. If I do the sum, if I do the sum, I would get 0. Here, this is the parity bit. I had 3 1s. So if I do the binary sum over those 5 bits, I would get 1. But I don't want it to be 1, I want it to be 0. I want it to be an even number of 1s, if you will. So I add another 1, and now that's the parity bit. So whenever I sum across all 6, I should get a binary result of 0 whenever I do the sum. So if ever I receive a block and I do the parity sum and I get a 1, well, I know something went wrong. I don't know what went wrong, but I know something went wrong. So that's what's about the goal of parity, is to identify that an error occurred. So you can ask, how effective is adding one parity bit? How much good do I get? Can I quantify how much better I'm doing? So we can calculate the probability that I will detect an error, or that I will miss detection of an error. So let's look at how I would do that. Well, in probability theory, it's a combinatorics question that I would end up calculating. And so the first question I'll ask myself is, suppose that there are j errors in a block of n bits. How many positions are there? So that's easy. That's n choose j, the binomial coefficient. So n factorial divided by j factorial divided by n minus j factorial tells me in that block of n bits how I could place j errors. Okay, so that's how many blocks have j errors in them. Now, if I say, what is the probability of getting j errors in n bits? Well, I would take the number of times it could occur times the probability that it would occur. So what is the probability of getting j errors? So assuming that, this is the probability of bit error is p, then p to the j, there's j bits in error, and 1 minus p, the probability I won't have an error, would be raised to the power of n minus j. Those are the number of bits which were not in error. So this is a classic calculation of the probability of having j errors in n bits. So when am I going to miss an error? When am I not going to detect the error that I should detect? And that's going to happen when I have an even number of errors. So if one bit gets flipped, well, then the sum will go from being a 0 to being the sum is 1. But if I flip 2, then I'm going to get a 0 and I'm not going to detect the error. So that's a mess up. So anytime I have an even number of errors, I'm not going to detect, my parity isn't going to work. I'm going to have an error and I'm not going to request a retransmission, and so the parity won't work. So how often does this happen, the probability of missing? Well, I'm going to do a sum, but I'm always going to look at even number of errors. So in here, it's only 2 times j, and I sum over 1 to n over 2. And so this gives me the probability of non-detection, not getting the error, not catching it. So that's parity. And so we can analyze the parity and see how effective it is. It is possible to also use vertical and horizontal parity. For instance, we would add a bit so that we could get the parity. So we would put our blocks of data and fill them up like in a matrix. So you take the sequential, and we would start filling them up with 5 bits at a time. And then once we have built our matrix of 5 by 5, we would add parity bits for the rows, parity bits for the column, and then a parity bit for the parity bits. And this allows us to actually correct some errors. So if it occurs one in each column and one in each row, then I can catch it. So it's a more effective parity. So this is where we sort of bridge the gap between parity just detecting errors and also being able to correct some errors, but you can't correct all of them.